DRAM versus SRAM. Which one should you choose? Ever wonder what makes your computer tick so fast, or sometimes so slow? It often comes down to memory. We're diving into the fundamental differences between DRAM and SRAM, two crucial memory technologies that power your devices. Before we begin, be sure to subscribe to NinjaOne's IT Video Hub and our YouTube channel for more tech content like this. Why DRAM and SRAM matter. In any computer, memory is the backbone for processing data quickly. Understanding the core types, specifically DRAM versus SRAM, is essential because they play distinct roles in your system's overall speed and efficiency. These technologies emerged back in the 1960s, each evolving to meet different performance demands, and their combined use optimizes modern computing. Demystifying DRAM, how it works and its specs. DRAM, or Dynamic Random Access Memory, serves as the primary working memory in most computing devices today. Each bit of data is stored in a separate capacitor within the chip. Because these capacitors gradually lose their charge, DRAM needs regular refresh cycles to keep data intact. This dynamic nature makes it highly dense and cost-effective. Typically, DRAM has access times ranging from 10 to 70 nanoseconds and refresh rates of 32 to 64 milliseconds. Modern modules can offer capacities up to 32 gigabytes per chip, with higher capacities under development, consuming about 1 to 3 watts per gigabyte when active, with voltages around 1.2 volts for DDR4. Exploring SRAM, the high-speed memory. Now let's explore SRAM, or Static Random Access Memory, a fundamentally different approach. SRAM stores each bit using a bistable flip-flop circuit typically composed of 6 transistors. The term static means data remains intact without periodic refreshing as long as power is applied. This design results in significantly faster access times, generally 0.5 to 2.5 nanoseconds, with no refresh required. However, its complex cell structure makes it considerably less dense, typically 1 to 4 gigabytes per chip, and more expensive per bit than DRAM. SRAM consumes 3 to 5 watts per gigabyte when active, but has very low static power draw, operating around 1.8 volts. DRAM versus SRAM, a deep dive into performance and use cases. When choosing between these two, key differentiators are speed and latency. SRAM is ideal for ultra-low latency applications like processor caches, L1, L2, L3, due to its consistent sub-2 nanosecond response times. Density and cost. DRAM provides higher density at a lower cost per bit, making it the choice for main system memory to handle large datasets. System integration. Modern systems use both. SRAM resides at the top of the memory hierarchy for speed, while DRAM sits lower for capacity. This layered approach ensures high-speed access for frequently used data and sufficient capacity for larger workloads. The choice between DRAM versus SRAM depends on your specific system needs and workload. If your priority is more memory for less money, DRAM is usually the right pick. However, if speed and low latency are paramount, SRAM excels. Matching the memory type to your specific requirements will help you achieve the best performance and value from your computing setup. For more information, check out our official blog post on DRAM versus SRAM. Which one should you choose? Linked in the description below.